Okay, so this is what we are going to learn today. Now that we've looked at how to convert degrees into radians and radians into degrees, today's lesson is on sine wave, cosine waves. You heard about sine waves before, yeah? You see them everywhere. So if you plan to do any engineering work, you've listened to music. So sine waves are part of what would make the sound that you hear in your ear, yeah? Eardrums. So I'll send you this paper. And if you struggle with some of the lessons, I've put a YouTube link here that's got quite a few of these lessons as well that you can watch with someone else's. Okay, so if you wanted to see a bit more, you can always use these. They'll be made available. So there's the sine wave. What is particular to the sine wave? What is the period of a sine wave again? 360 degree, yeah? It just repeats itself every 360 degree. What's the amplitude? The amplitude is 1, so we go from +1 down to -1, and we pass at +1 at about 90 degree and 270. That's when you've got -1 for the sine wave. Okay, so sine wave, you kind of need to know what it looks like. Done that at that 5 level. Okay, so now what is the cosine? First of all, what does cosine stands for? Has someone ever thought of this? There's the sine, and I'm telling you, that's the one that I know by heart because I've used it quite a lot. How do I find the cosine? What does CO stand for? Anyone got an idea? CO? Anyone remember what we said when you've got two angles and you add up and they make 90 degree? What did we call those angles? S1? One angle complement the other angle. Do you remember that? Complement angles. So complementary angles are two angles. When you add them, they give you a right angle. So basically, co here stands for complement of sine. So it's the complementary of sine. So what do they mean by that? Is if I find sine 30, what is the complement of 30? What do I need to add to 30 to make 90? 60. It should be exactly the same as cosine 60. Can you check that for me on your calculator? If you type cosine, if you type sine 30, hopefully, if what I'm telling you is correct, then sine 60, cosine 60 should be the exact same value. Yeah? You can check another one. What is cos 45? So your calculator might say 1/√2. Have you noticed that sine 45 is the exact same value? Because what's the complement of 45? 45 itself, yeah? So that's the two angles that have got the same value. And now you can see if I've got here the cosine signal at 45 degree, when you reach 45 degree, you'll have exactly the same value here. Yeah, at that angle here, we have cosine equals sine. Complement, so complementary, supplement angles is when you add them, you get 180. Okay, so that's where it's coming from. So anyone knew this? No? No? But remember, you learn complementary angles maybe one day. So It's always good to remember those things, okay? So what we find is cos 0 is 1. So what's the complement of 0? What do I need to add to 0 to make 90? 90. So that's why sine 90 is 1. And if it's sine 0 is 0, then to get sine 0 is 0, that means cos 90 is 0. Yeah, so you can see the complementarity between the two, sine and cosine, okay? So you know a bit more about the sine wave now. That means if you know one, you'll be able to pull the other one quite easily. Okay, so we've got those two signals. And in order to solve trig equations when you were at National 5, maybe your teacher came with an easy way to find all the solutions. Remember they used that diagram, CAST, yeah? Does that ring a bell? The CAST diagram, so you probably called that quite a lot. So basically the CAST diagram will help us to get all the solutions that we need. So what you look at here is, in how many quadrant have I got here? So how many quadrant? 4. So the first quadrant, because we've got a period of 360, remember the full circle makes 360, the first quadrant is going to be 360 divided by 4, which will end up at 90. The next quadrant between 90 and 180, then the next quadrant between 180 and 270, and the last quadrant from 270 to 360. So now what did we notice? Okay, so for your assessment, you're only going to be asked to work on sine and cosine, but just because we use cast, I've added the tan signal as well, yeah? Tangent is just the sine of a cos, okay? So can you see in that first quadrant, all my signals, are they positive or negative? They're all positive, and that's why we have, every time I'm going to get an angle here, whether I'm solving a trig equation with sine, cosine, or tan, my angle is going to be positive when my solution is going to be positive. Sorry, my solution will be positive. The angle is going to be between 0 and 90. Okay? What's your name? Sorry. Your name? Ryan? Okay, so in that second quadrant, so the first quadrant we said was 0 to 90. In that second quadrant between 90 and 180, can you see that there is one signal that is positive? Which signal is positive in that second quadrant? Sorry? Which signal is positive in here? Is that the red one or the blue or the purple? The red one, which is, what did we say the red was? Yeah, sine. So that's why sine is positive in that second quadrant. So if I get to solve an equation where I've got sine of an angle is positive, so I know that my answer is going to be in that quadrant and where it's all positive. In that third quadrant, it's just tan that is positive. You can see the tan signal here being positive. And in the last quadrant, it's only cosine that is positive. Okay, and that's where we're going to have our positive, the second positive answers. Remember, they're all positive here, but you've got cos positive here as well. And that's why you have two answers. But if they're not, if cos was negative, my answer's got to be where it's not positive. So if it's positive here, it's got to be negative on that side, okay? And you can see it because cos is positive here, first quadrant, and positive here in the last quadrant, whereas negative in the second and the third quadrant. And that's why people use cast, because it makes it easier for them to see where all the signals are instead of having to draw them. But I would rather you understand where cast comes from. Because if one day you can't remember cast, I hope you'll be able to remember that sine signal. Because that's the only one that you need to remember if you think about the cos just being the complement of the sine, yeah? So you guys knew where cast came from, yeah? Did you have an idea that it was based on the signal themselves being drawn? No. So remember, you'll be able to remember this better now. You've seen where it's coming from. Okay? Because rote learning would get you to pass an exam, but it's not going to develop you the skills that you will need in 6 months, in 2 years' time, in 5 years' time, especially if you want to do more. Okay? Whether you do engineering or whatever you're going to do, you will need math. So now is a good time to try and understand what you were doing. Okay? So now that we know where all the signals lie, so what we said was, if I'm given sine x equal a half, for example, 0.5, because I've got in my head cast, I know that C is here, A, S, and T, yeah? All positive, sine positive. I know that my answers has got to be between 0 and 180. Okay, if I get cos positive, cast again, you start bottom right, and then you go up that way, cast, positive here and positive here for cos. So the two answers are going to be here. Unfortunately, when you use your calculator, which angle does your calculator gives you? So what is the angle that would make cos x equals 0.5? How do you find that? How would you solve this? Cos x equals 0.5. How do you solve that? What's the opposite of cos x? Inverse cos, yeah. And what on your calculator, how is represented inverse of cos? Cos to the power -1. So in order to find x, you need to take the inverse of 0.5. So shift cos, which is cos to the power -1 of 0.5. What did you get? 60 degree, yeah? So have you noticed your calculator only gives you one answer? And did I not tell you there was two answers? Because cos is positive here. Within 360, there's another answer here. How would you find that second answer? So let's say this was 60, yeah? How do I find this one? So imagine you've got 360 here. And I'm trying to get here. So basically, to get here, to get to this angle here, I need to do 360 and then take away that 60 degree. So what's 360 minus 60? Okay, now, can you check that cos 300 is 0.5? So if you type cos 300, hopefully it should be 0.5. Yeah. So that's why you need to know that cast diagram to solve these, because unfortunately, your calculator only gives you the answers between 0 and 180. Okay. It won't give you the other one. If you were to do this here the same, it will only give you that one. And to find the other one here, you need to do 180, take away the angle. We'll look at some example. Okay. Nat 5, solving trig equation. Yeah. You guys remember doing that? That's why you use cast. So if we're asked to find a negative value, then we need to find, first of all, this angle. So we treat it as if it was positive to start with. Once we've got our angle, then we do 180 plus the angle to get this one, and 360 take away that angle to get this last solution. So technically, when you've got to solve a trig equation with a negative value, you're going to have to do 3 calculations. One to find the positive associated angle, if it was positive, and then you do the 180 plus and 360 take away. Here it's 180 minus the positive and 180 plus. Okay, so there's quite a few manipulation to do. So basically, this is the summary of your cast diagram. We said here they're all positive, yeah? Let's say you find that angle called, sometimes you see people calling it alpha or A. So that'd be your positive angle. Sine is positive, not only here, but at 180 take away alpha. So here you would say this is 180 minus alpha, because you would go full 180, but you need to come back. So you take away alpha. Here you get 180 plus alpha, but on this case here for cos, you would go 360, take away that angle. So here you'll have 360 minus alpha. So the only thing you need to remember is where to put CAST, and here I've got 180 plus alpha. Here I've got 180 minus alpha, and here 360 minus alpha. That's the only thing you really need to remember to solve your trig equation, yeah? To be honest, I only remember alpha because I know this is 180. To get less than 180, I need to take away alpha. This is more than 180. To get more than 180, I need to add alpha. Here, this is 360. To get a bit less than 360, I need to take away alpha. So if you've got that in your mind visually, you only need to remember where the small alpha is, yeah? And just use your primary school circle skills that you learn, yeah? Because that's what I keep saying to folks. Math is not just, I'm going to learn it and pass the exam. I'm asking you a question that probably you've learned at primary school. And that's what you need to keep remembering, okay? So remember, we said we're going to work on either degrees or radians. So now when you get to the higher levels for math, we expect you to know radians as well. So you can either change it right from the start, or some people are quite happy to just work with radians. Okay, so it's exactly the same thing, but here you've got, instead of 180, you've got pi. Instead of 360, you've got 2 pi. Okay, instead of 90 degree, I've got pi over 2, 3 pi over 2. And whenever you see alpha, you've got pi minus alpha. Okay, but most of the example that I will give you, we will switch into degree. But if you're happy to just work only with radians, then it's up to you. Okay, you get the same mark, but make sure you don't make a mistake though. Okay, so we see more mistakes being made when people use the pi, because again, it's to do with being more able to see 360. Yeah. Okay, so we've already done this question earlier on, yeah? So how would we solve the equation sine x? You know, when I say to you in math, whenever you're gonna get a mark, you need to play that game where you're gonna get the marks. How do we get the marks? We show our working. You've heard teachers telling you that all the time. Show your working, show your working. That is to do with the fact that if you make a mistake, if your working was okay, but you made a mistake through your working, you don't get penalized twice. Okay, but if you just come from that and say, answer, that is 60 and 300, you will get a mark. But if you say answer is 45 and 300 minus 45, you'll get 0 mark. Whereas if you put some work in and you show where you made a mistake, then you still manage to get some mark. Yeah. And that's why I said to you, one day there's someone who went through the whole Nat5, passed, never got one answer right. Just some workings. Okay, so sine x equals 0.5. What did we say? Yes, think about it as well graphically. What we were trying to solve here is the sine wave. And I said that it should be equal to 0.5. What are the angles where they both touch? There's one angle here. And then there's another angle here. Yeah. And if I look at that angle, this angle here, if I find it, this one is just 180, take away that. That's where your cast comes from. So inverse sine of 0.5, we said was 30 degree. We look at cos earlier on, but 30 degree is this angle here. Yeah, through your inverse sine. So that means on the first quadrant, I found my answer, what we called alpha. We found it. Now I need to find the second one. And remember what we said, looking at the graph, you can see that it's 180, take away that angle, or if you prefer using cast, alpha here, then 180, take away alpha here. So what's 180 take away 30? 150. So then you put the second answer, and then this is where you get all your mark. So this question would be 2 marks. Okay. But you're not going to get something that simple. That is not 5, but you need to be able to get to the simple parts first before you get to the more complicated part. So for most of you, this should be revisions, right? Is that new for some people in the class? Is it something new? No? Because remember, you were asked to come to this level with at least a Nat5 type level. So even if you don't remember because you've done it a long time ago, you should now start pulling back memories, yeah? Anybody finding that completely new? No? All okay? Good. So I like to hear. So that was the first example, and we found the 2 points. Now, what if I'm asked to solve this equation, cos x minus 0.625 equals 0? Again, this is what's given it for me in that range. So they're looking for you to give it in degrees. If it was between 0 and 2 pi, then you need to give the answer in radiant, okay? So in that range, how would we do this? How do you solve an equation? How would you solve x minus 5 equals 0? So you put, yeah, you make x the subject, yeah? And then x equals 5. Yeah? Now I've got cos x minus something equals 0. First thing you do is you make cos x on its own. So how do we make cos x on its own? Remember, I've got an equation here. Whatever I do on the right, I need to do the same on the left, or quite a few of you have been told, you take that number, if you move it on the other side, you change the sign, yeah? That's usually what you've been taught, but that's what it is. We just add plus 0.625 on each side. Then that will cancel these two, and here I'll have 0.625, yeah? That is the basic of solving equations, yeah? Now, how do I find cos x equal 0.625? Your best friend? So you're going to say to yourself, okay, I've got a cos signal. I'm looking for a positive values. If I put cast, I know that my first positive value will be where it's all positive, between 0 and 90. So that would be your first one. And where do I see cos positive again? In that fourth quadrant. Yeah. And that fourth quadrant we said was 360, take away my angle. So what did you find for the first angle? Shift cos 0.625. $51.32, yeah, or 51.3. As long as you state how many decimals you've rounded to, then I'm happy. So basically, that's what we're trying to find. Cos equals 0.625. Two answers. One is going to be here, a bit more than 45, and the other one is going to be here, 360 minus that amount, okay? So 51.3 is my first answer in the first quadrant. And the last answer should be in the fourth quadrant. And we said that for the fourth quadrant, we're at 360 take away that value. So 360 take away 51.3. You should get 308.7, yeah? And you've got your two answers. This, during a test, would be 3 marks because you're going to solve the equation first, and then you're going to find the 2 points. Okay? The 2 points are here and there. So far, so good, yeah? Trig equation. Guys, we really need to be able to do these because during the assessment, Trig counts for about 6 odd marks or something. So, but it's going to be more complicated than this, obviously. But once we know how to do the basic ones, we should be able to ramp up, okay? So, now if you're asked to solve √2 sine x plus 1 equals 0, again, this time they've asked me to put it between 0 and 360. So I'm expecting you to give the answers in degrees. How would you do that? So give it a try. Okay, so we've decided we're going to find alpha first. And in order to find alpha, I just need to do the inverse sine of 1 over √2. So first of all, as you can see here, third and fourth quadrant is what I'm looking for. But I need to find that angle if it was positive, 1 over √2. So what did we say we're going to do? Ignore the minus sign. Find the related angle in that first quadrant. This can be used to find the required angles in the third and fourth quadrant using CAS if you want. Okay, so all these are in your notes. So what we said was we're going to do inverse sine of 1 over √2. If you do that, you get 45 degrees. Then we need to do in the third quadrant 180 plus 45 and 360 minus 45. And those are my answers. And 1, 2, 3, and solving the equation, you get 4 marks for that kind of questions. 1 to solve the equation, 1 to find the positive angle associated with it. That means even if I had made a mistake here and I put 30 degrees and I still get these two okay, you will still get these 2 marks. Okay, remember, you don't get penalized for making a mistake and carry on the mistake. Yeah, and that's where showing your working comes to play. Because on 4 marks, I can make 1 mistake and still get 3 out of 4. All right, so worksheet 7. I'm gonna let you do a bit. So what we'll do for you to work on only one question 1 and 2, and just do B and C for each of them. Okay,